my name is Andrei Sitnik, and I'm lead front-end developer in Naval Marshal's team. In border officers always ask, is it a real name of the company? They don't believe it? Okay. But you may know me because of my open source with the same fancy logotype. And all this project was created about 5 years ago. I'm sorry, initial announce was only on Russian, so speaking of internationalization, there is no English version of it. So, it was announced 5 years ago, and lucky, it became popular. To be honest, there were many different projects which sometimes were better than mine. I was just lucky. For instance, CSS3, Stankao. Check it out. Anyway, right now post CSS and auto prefixer, as any big and popular project, they don't need new feature. We add anything that people want. And so right now, I have a problem. It's similar with a child. You always know that your children will leave your house, so same problem with me. And this is why I start to think what will be the next big task. Because, yeah, I know this option, like, after work, having a free time, I don't know, watch TV show, and we can go somewhere, but this is not my option. I want to be burned out in open source. This is why I start to ask the question, what will be the next big project, big problem to solve? Of course, first idea is GraphQL. GraphQL is a really amazing project. If you don't use it right now, try it. It's really amazing. I really like it. It's really solved lots of problems. But there is only one problem with this project for me. It's the problem that most of the problems, like most of the questions, are already solved, already answered. And to be honest, I don't want to say that promoting and polishing the code is like very silly task. It's promoting new ideas is so complicated. I'm so glad that there is people who do it because it's really hard work. But this is not a project that I want to spend time, because I want some project when we even don't have a questions, not answers, not even answers. So I start to think, what we will have after GraphQL? What system we will use to connect our client and servers? And I found a solution after a talk of Viktor Grishenko. He is a Russian mad scientist in distributed system. And he presented Crdt in that talk, and I was convinced. I really right now believed in this idea that Crdt will be the next. But it is only my opinion, of course, so I don't push you. But I will try to convince you. And I will try to convince you in this way. I found that most of the big revolution started in the same 3 steps, have the same pattern in the beginning. Initially, it was, sometimes very small, but it definitely non-standard idea, something out of box, because this out of box problem pushed us to be out of the box. Because this problem is non-standard, we can't use standard solution. So people went to the history to find some old ideas to solve it. Why old? Because we are living in postmodern area and all ideas was created. Deal with it. And in the end, when they solved this very small non-standard problem, they mostly found that this solution can be applied to anything, that this solution is not only for this small problem. So because I'm using a ships in my presentation, of course, really similar to Opening America, it was just a trip to India. But more important example is React. Initially, it was created just to solve the problem with notifications, and to do it, they discover functional programming. Functional programming is more than 50 years old, and for the most of the time, nobody uses it. And right now, we all use React, at least some of you, and right now, we all can say that we are functional programmers, at least. Because it was very similar with Redux. Initially, Dan Abramov was maintainer of React Hot Reload, and he prepared a talk about how to write your program perfectly so this program will be hot reloadable. To show this example, to show the way, he found a very interesting idea in Elm. Elm is a really amazing framework, but unfortunately, nobody cares about it. It's very sad. It's really, it contains a lot of good ideas. So then Abramov took the idea from Elm to show how to write programs for hot reload. But right now, this is the most popular state manager, and people use it even without, mostly without hot reloading, because it really don't work sometimes, most of the times. So, I will describe you why Crdt is so cool in the same 3 steps. An initial step, we need to find very unusual, very unique problem that we can't solve with the current frameworks. So the problem to do application. You can put a name, you can put checkbox, you can put likes with counter, and you can put description. I know what you want to ask me. Like, are you sure that it's really unique, non-standard problem? Because this is a problem which we all prepare to solve perfectly, maybe the best problem for us. We can just copy-paste the code from the guides, from the articles, and it works. Yes. So, we will do the same. We will just copy-paste the code, I don't know, maybe from Redux. How many people here use Vue or in Vues? Or we can use Vues, it will be the same code. Of course, we need to save our task on the server, so we will make a JAK request. If we are a very good developer, we will care about the errors, network errors. But to be honest, most of the developers don't care. Or we can go GraphQL way, because GraphQL is really awesome, and we can use, I don't know, all this cool stuff with GraphQL, with mutations. And that's all. We made a perfect to-do application. Where is our money? But then, our client asked about a very small detail that he or she forgot. That all these tasks should be edible in the same moment. That a lot of different users will work on the same task in the same moment. Like, is it easy to you to add? Oh, of course. Okay, how we can deal with it? First idea, we can do some hacks, you know, to put some crazy stuff. I don't know, to ask our clients to resolve the conflicts, because if 2 people work in the same data, in the same tasks, they always will have edit conflicts. They will always try to edit the same tasks. This is a human nature. This is a nature on our internet. And so we need to resolve conflict. We can do it manually, but it's not an option, absolutely. It's like a very bad way to do it. Why? Because machines must suffer, not humans. So we need to do something automatically. So we can do some hacks, try to do it with GraphQL or JAX and without success, or we can start our long journey to dungeons of computer science. To be honest, this journey will be very quick. We will find a distributed system created about 30 years ago, ideal distributed system. So, distributed systems. Right now, when we are making our JavaScript application, we mostly, have our client code, client-side code, and some server-side code which we don't care. Sometimes we even don't speak as backend developers. And we just send this request and don't care about how they will work. Will it have some problems, some errors during in the network? But distribution system is very different. The idea of distribution system is that everything, like the client side, the server side, all of it is part of the one system. And instead of sending requests, we synchronize the state. Okay, but it's theory. Let's go to the practice. How we will implement it in our task manager. Have an exact problem, have an exact project. So, as I told, we have a problem. If 2 people, or many or more people work in the same document, they always will have edit conflicts. So it could be possible that 2 persons change the same document and save it to the server. Right now, with Ajax, and mostly with GraphQL, we send the state to the server, and server somehow should merge it, but it's incredibly hard, especially in Chinese. So we need to do something. And there is a very good idea that if you have a problem with algorithms, it means that you have a problem in data structure. Fix your data structure, and then algorithms will be simple. So let's do the same. The idea called event sourcing, it's very old idea, and the idea is that we don't send and don't request a state from the server. We send and request operation, what was actually changed. It was very similar to the yesterday talk about microservices and all these messages. So, in this case, we don't need to merge the conflict. It's obvious how to do it. We just need to put operation to the database, and then other clients will ask us about the state. We will send the same operation. We don't need even an algorithm. It's very easy when you start to think about operations. This is one idea from distributed systems. But what is operation? We have a real project. We need to do something in our task manager. So what will be operation in task manager? And we don't need to create something new. In Redux, we already have actions, similarly in Vue and many other frameworks. And these actions, by definition, it's description of the smallest operation, what user actually changed. So our operation will be Redux actions. I will show example in Redux just to not blow slides. I really like Vue. So, and when we start to think about it, it changed a lot. Let me explain how important this idea that we just synchronize Redux action. So, I don't know about you, but I really like to remove a code during refactoring, especially when I did not write it. So, because we start to use distributed system, we can remove all AJAX requests, all this code, all the systems that we are doing our application. No AJAX requests. Let's remove it. No mutations, no saga, nothing. Just pure Redux with a few extra things. And we even simplify, we even remove things from design. We don't need these loaders anymore because I hate them. So, instead of all these things, we will have open WebSocket connection to our server, between our server and our clients, two-way connections. And when user will do something, we will dispatch a Redux action, apply it immediately to our interface without any loaders, and then in the background, we will synchronize this action with server. So we don't need loaders anymore. We will apply changes immediately. Optimistic UI. By the way, the term optimistic UI was created in the Google Wave. Who used Google Wave? Wow, so many. So it was initially created. It was initially created in the Google Wave for Google Wave. This idea. So we will synchronize our actions with the server. Server will save our actions to the database, but in the same moment, it will receive the same action to any other connected clients. So any other connected clients will see our changes immediately. Not because we do something, just because our architecture. Next. But if we have two-way connection, we can create these actions not on the clients, but we can create Redux actions on the server. The same thing, and then send it to the client. The idea allows us. Okay. It was optimistic UI, but what if we want a pessimistic UI? For instance, I don't know, payment. You can't make optimistic UI for payment, you really need to wait answer from the payment backend. In this case, we will do a tricky thing. We will split our tasks to two actions. One action will ask server to make a payment, and when we will dispatch this action, we will show a loader. Or sometimes we need a loader, I understand. But when server will finish payment, he will create new action, and this action will be synchronized because we have a WebSocket connection to our client, and client will show that everything is paid. Interesting idea that if we will have no connection in the between, the system will still work. We don't need to make other requests. Very easy. Okay, but I know what you want to ask me. Like, Andrei, you're talking about very simple cases. Ideal cases, about some utopia. Unfortunately, in the real world, it will be much more complex. We will not have Wi-Fi. A lot of the problems. You know, like, never trust a person if you did not see them with very bad Wi-Fi connection. What if we will have the same bad connection with our idea of CRDT, how it will survive? And this is completely not a problem. First, of course, we need, if our WebSocket connection is down, we need to show some warning that everything right now is offline, but we don't need to block our user interface, block user from changing something. User can continue change any tasks. Why? Because already Redux can store actions for you. You do it already in Redux DevTools. So it's we completely have the same thing. And as a result, when user will do something in offline, Redux will store it in the memory, and then we will have a connection. You will synchronize all this stored action with the server. So it will be offline first by design. Next problem. But what if it's database error, or maybe even worse? What if this action is illegal? Can it be applied anymore? For instance, I don't know, we can rename our project, but this name could be already taken. And again, in Redux, we already have a solution. In DevTools, you can undo any operation. You can do time travel. You know, like we all want to change something in our history, but in Redux we can do it. And so we can apply the same approach to solving that problem. If user, for instance, rename the project A to project B, we change interface immediately. In the background, we send this action to the server. And unfortunately, after a minute, server understands that this name is already taken. We can't apply it anymore. Or we need to pay, I don't know, $20 for the rename of the project. In this case, server will just send a special action, which will ask Redux to make a time travel to undo that illegal operation. It's already possible right now. A lot of people use it. And in this case, we will just change the history, and the project will have its old name. Okay. But let's go a little deeper, because that two problems, it was a simple problems. Because when you speak about the distribution system, it's very easy when it's inside your mind, but it's very hard when you start to write it in the real code. Okay, we have multiple clients. They all create actions and send it to the server. It's completely a mess. As a result, it could be a situation when order is different. To be honest, if you're working in some company use distributed system and you found that order is unstable, run away from company before they fire you. It's impossible to fix. Sometimes it's just much easier to burn everything to the ground and start again. It's a really hard problem. So we need somehow be sure about the order of our actions. First idea, we can use some time, yes, and sort our actions by the time. In this case, we will have the same order in any machine. Unfortunately, time is really complicated. It's very easy when it's on your watch, but in distributed system, it's not. Okay, first problem, sometimes time can have same value, and so we can use it for sorting. My favorite problem, sometimes time can go back. First, because there is time synchronization, but my favorite reason is leap second. In most of the years, special committee look about the position of our planets and decide to add or remove 1 special second. Mostly they add 1 special second to finish everything that you did not finish in this year. In this moment, time goes back to the 1 second. And so all our order becomes insane. Like, we can't use the real time. And of course, unfortunately, time is relevant. And any clients have a different time, this is not a time zone problem. It's mostly because some people, when they go to different cities, they don't change time zones, they change actual time, and it's messy. Okay, let's go back to the dungeons of distributed system, and there we will find a very good idea. Let's remove the time. It's called logical clock, created 40 years ago. It's the idea about time without actual time. It uses counter. Every time when you generate a time, you increase this counter. Of course, you add unique client ID. But the most important part, when you receive action from other clients, you check the time in this action. And if this action contains a bigger time, you increase your counter as well. So the first client creates time 1, it sends it to the second client, and second client will use time 2 because client knows that 1 is taken. Of course, sometimes it could be a situation when they create time in the same moment. This is why we need unique client ID to have a difference between time. Okay, we solved this problem, likely. But somebody may think about it, that in previous problem I saw a very easy case when 2 clients change different fields of our task manager. One client change a likes, a different client change a name. But what if they will change the same field of our database? We need somehow to solve it. So it will be the similar idea to Google Docs, because we have a description, and we must allow users to change the description at the same moment. But how we can do it? It's like this rocket science. But to be honest, it's not a rocket science. It's mostly a question what we will put to our Redux action, how we design the system, what we will put inside. And this is why we need to go back to the engines. Yeah, I like the engines. And we will find Crdt. It's very new scientific paper created by this scientist. There is a reason why I put their photos on the slide. When I have this talk on the importer, speaking about the same problem, about Crdt, after the talk, I go to the area, and one person started to ask a very hard question about me, like, it was not a logic, it was not vector clock, it was logical clock, and so on. And like, why are you asking this question? Like, why it's so hard? And then I recognized that it was one of creator of Crdt. But he liked the talk. It was very stressful time in history. Okay, so Crdt. Finally, in the middle of the talk, I finally say about something about Crdt. Crdt is conflict-free replica data types. It's a data types, a very big list of data types. All the data types are very different. Some types use time, some types use operation, some types use state, some of them use distributed time, some are not. They are very different. But they have something common. First, they have limits. Unfortunately, it's not single bullet. Second, they have operation, what you can apply to these types. But most important part, there is idea behind all these types. This idea that every client could create this type, could create operation without asking any server, without asking any master. And as a result, when everyone will synchronize all operations, they will have the same state. This is a core idea. So unfortunately, post client create operation about renaming, but because that client created later, everyone start to use name A because it was created later. Okay, so we need to open Crdt and read about all this operation, and we can use this operation to create our Redux actions. For instance, instead of setting likes to exact number, we will use increase and decrease. To be honest, it's a very obvious idea. Let's go to a more complex idea. How we can change the text in the same moment, two persons change the same document. What we will put in Redux action. First idea, of course, we can make it atomic, and we can put like index in the Redux action, like remove symbol in the position 1 or add symbol to position after position 1. This is not an option, because every time when we change something with our text, the indexes will be changed. This is why we can't use this way, because it is not really atomic. It depends on the previous history, and if you put something in the middle of this history, the whole system will be broken because indexes will be changed. Okay. This is why when somebody will remove C from the beginning and second user will add H, the result will be the mess. But the solution is very simple. Let's use persistence indexes. So when somebody will remove the symbol at position 1, we will keep the numbers. And if person will insert letter between 1 and 2, position 1 and 2, we will use position 1.5. In this case, indexes will be persistent, and everything will be work without a problem. So this is how we will solve the problem with conflicts. We will use Crdt to make a Redux action. But unfortunately, Crdt doesn't solve all the problems. This is why we must use Crdt mostly as inspiration. Sometimes you need to think for yourself, unfortunately. So, let's start from the beginning. We use Redux, Vue, or any other state manager. Then we put a time, distributed time to any our action. Then we synchronize actions, not sending a JAK request, not making mutation. We just synchronize it by WebSocket. And four, we use time travel to insert actions in the middle of the history. If it was created in that time. And also we use time travel to remove illegal operation from the history. And in the end, we use Crdt as inspiration to make our system, to make our actions. As a result, we made very good collaborative to-do application. We resolve our non-standard problem. But maybe we create something bigger. Maybe this idea that we created changed something else. Let me show one example. User, very fast, click on the checkbox and then remove the checkbox. The final state is on. But unfortunately, sometimes backend will receive our JAK request in the wrong order. Unfortunately, it happens. TCP guarantee order only in the one session, and every JAK request is in the backend session. This is why, in the end, we will have a different state in our database. It happens right now in many applications in the real world. But if we will start to use Crdt, if we will put a time to any operation, server will ignore time from the past. And this is why this problem will be solved automatically. Developers doesn't need to think, and I know you're all lazy. I'm lazy as well. It's much better when system protect you from making mistakes, not you must protect system, because machines might suffer. Why Crdt is so better for this case? Because a JAK request and other solution was created for perfect internet on your local machine, when backend and client side is the one machine and everything is perfect. Unfortunately, real internet is a little different. And Crdt was designed especially for this internet, for unstable, for bad internet, with wrong orders, with broken servers. This was a design idea. And this is, unfortunately, it's a really big problem. My family lives in China. I really like to visit them because I really like borscht of my mother. But in internet, in Chinese internet, 40% of Western websites, in Western websites, 40% of packages are lost because of the censorship. Even if you're accessing to a legal website, they will just cut half of the packages of any Western website. And it's insane to use any current application. But I will not speak about some other countries. New York, we are this city. It doesn't have a very bad internet in the subway, and we must deal with it. And of course, next billion people will definitely not have a good internet, and we must think about it. And this is why, if you use Crdt initially designed for bad connection. As a result, your client will be able to use your website in bad connection. More clients, more profit. Crdt was designed to work on the bad connection because it was designed to be peer-to-peer protocol. It's not one server. It completely was designed to be absolutely peer-to-peer protocol. As a result, you can use these possibilities to make some tweaky system inside your company, inside your product. You can use multi-master replica, or you can, for instance, make the same replica on client side. For instance, only one browser tab will keep a socket connection, and it will synchronize new action with other browser tabs. We already implemented in our frameworks. It's not so easy in Crdt. Or you can do completely mesh system with Crdt. I know the project which use Crdt to make a mesh network, for instance, to work in Cuba in some similar situation. So, Crdt is peer-to-peer protocol. It's much easier to scale it. It gives you more options. As a result, you have more options to make a high-load website. But my favorite feature of Crdt is that Crdt was designed to be optimistic UI. Because when you implement optimistic UI, you must care about offline first. There is no way how you can be sure is it offline or is it online. This is why before you will make a request, This is why it is important to take care about offline first if you're making any optimistic UI. And if the system was designed to work in offline first, it will be much easier to have optimistic UI in the system. So, first, because it was designed to work in WebSocket also with offline, because it was designed to work in the WebSockets, you can make live updates. It is automatically, it's out of the box. As a result, your user will always see the final state and will make less mistakes. It's better for your business. But more important part, that performance really matters on your revenue. It can change your product revenue. As a result, because CRDT was designed to work with an optimistic UI, you can make optimistic UI for your product. It will not be faster, really faster, but user will think that it is faster because there is no loaders in the middle. And as a result, they will think that your application is faster and they will like it more. As a result, it will affect on your revenue. This is why right now, CRDT is becoming a trend. A lot of people speak about it. It's already implemented in Atom, Teletype, in Visual Studio, in Redis, SoundCloud use it. But I'm suggesting to use CRDT for the regular web application to make it work better with a bad internet. Because we all have bad internet, even in big countries like the United States. And this is why I really believe that CRDT will be the next big thing after GraphQL, because it is completely different idea and they solve completely different problems with bad internet, with optimistic UIs and all of that stuff. This is why there is right now a lot of solutions to deal with CRDT. Many solutions are very good, for instance, Node.js, created by that Victor Grishenko that I told you. And of course, I have my own solution. Please subscribe, like, and follow. But that's all. Thank you for listening with me. Let's go to lunch.